Our fourth factor is topography, which refers to the soil's position in a landscape. This heavily influences soil development, mainly by affecting water movement and soil wetness. Even small differences in elevation can lead to major changes in soil type. Now, when we're talking about relief or topography, we're dealing with two things: slope and aspect. Let's take a look at slope first. So, to discuss slope, think about a hillside. Okay, so we have this diagram here, and you're going to have different areas of this slope. Soils on the shoulder of a slope tend to shed water, right? That's steepest usually, and they're generally drier. Soils at the base or the toe slope often receive water from above, making them moister. Water can collect here, even creating wetlands where organic matter can accumulate. This is important to remember next semester when we're trying to delineate wetlands. Topography is an important thing to look at. Now, mid-slope soils are somewhere in between. The water table also tends to be deepest at the shoulder and closest to the surface at the base of the slope and in depressions. You can often see this effect on the types of vegetation that grow on different slopes, right? Just look at our hillsides around here and you can see different plant communities at the shoulder versus the toe. The other part of topography is slope aspect. You know what aspect is. It is the cardinal direction in which a slope faces. Again, jogging your dendro brain, let's think about this. South-facing slopes, and to a lesser degree west-facing slopes, receive more intense sunlight. That would make them warmer and drier. On the other hand, north-facing and east-facing slopes are generally cooler and moisture, which comes right from dendro, right? And then you can also kind of pick what plants would probably be there. These topographic differences have other significant impacts. For example, the chemical weathering of the soil is affected. Subsoils high on the slope, near the shoulder, might be reddish, indicating oxidized iron in a well-aerated soil. Makes sense because all the water flows down the slope. And then while at the base, they could be gray, indicating reduced iron in waterlogged conditions. Slope also directly influences erosion rates. Slopes tend to lose soil due to erosion, making them thinner and less well developed. Depressions, on the other hand, tend to receive soil. So while level lands might have drainage problems, sloping terrain often deals with erosion and dryness. In natural ecosystems, these differences are crucial in determining which plant communities thrive there. And again, this has something to do with next semester, we'll be looking at erosion rates due to slope. And with our wetland delineation, we're looking at those depressions. Finally, our last factor is time. Soils are dynamic entities. They don't just form and stop. They undergo a continuous aging process. Initially, you might just have a thin layer of young, immature soil appearing on the parent material. But over thousands of years, the soil will slowly continue to age, change, and develop, becoming a more mature and complex soil. This long time scale highlights why soil is considered a very slowly renewable resource. All right, we've hinted about this multiple slides and we've chosen to ignore it. And so far we've discussed 5 classic soil forming factors: the natural kind, parent material, climate, organisms, topography, and time. That's our Chlor PT, right? But what about us, humans? We often consider ourselves just another living entity that modifies soil. However, our actions can be so rapid, so dramatic, and fundamentally different from other life forms that many argue we should be considered a distinct sixth soil formation factor. Think about it. Very few soils on Earth have remained completely unaffected by human activities. These effects can be subtle, like the deposition of air pollutants, even far from our major cities, or they can be incredibly massive, such as the extensive earth moving involved in road construction. When we cut into a hillside to build a road, we're essentially resetting the time clock for that new soil back to zero. And the earth moved by the machinery becomes the brand new parent material for any soil that will form there. Much of what we do to grow plants, like intensive cultivation or applying fertilizer, fundamentally alters the soil's properties. We're going to learn more about that when we're learning the properties of soil, the physical and chemical properties of soil. One of the most fascinating and historically significant ways humans distinctly modify soils is through phosphorus enrichment. That's a big talking point on the Chesapeake Bay, right? The phosphorus nutrient issues. We tend to accumulate phosphorus in the soils around us, largely through 2 primary activities: fertilization of our crops and gardens, and the disposal of refuse, essentially our waste. This effect is so distinctive and long-lasting that it leaves a unique chemical signature in the soil. In fact, this phosphorus enrichment is so distinctive that archaeologists frequently use it as a compelling evidence of early human habitation. Can you believe that? If they find high levels of phosphorus in a soil layer that wouldn't naturally have it, it's a strong indicator that humans once lived there, perhaps for thousands of years. It points to past settlements, farming, waste disposal sites. It's truly our chemical fingerprint on the landscape. Our modern system of soil classification, which we'll cover more in Chapter 3, even recognizes such enrichment. Certain soil types are specifically classified based on evidence of human modification, including these distinct accumulations. It underscores just how profoundly and uniquely we impact the very ground beneath our feet. To summarize, soil formation is a complex and ongoing natural process. The diverse soils we see around us are the result of the intricate interplay of these 5 key factors: parent material, climate, organisms, topography, and time. Human activities also are so influential that we are often considered as the 6th factor. Understanding how these factors interact is absolutely crucial for anyone working in natural resources, as it directly impacts land use, agriculture, conservation, and overall ecosystem health. It helps us understand why one soil can be vastly different from another, even over short distances. That's it, kids, for this part.